Students, welcome back to the second part of lecture number 34. So, we are talking about how to mix different models, that is called hybrid models, right. So, let us first discuss about the first important advanced deep learning model. This is very important for material science. Please focus and try to learn as much as possible. This is called a deep transfer learning model, and it effectively uses previously learned model knowledge to solve a new task with minimum training. Okay, that is something which is new, right. So, it has to use some kind of a previous learning model. Okay, that is what it is. Previous learning model means I want to discover a new material, or I want to discover a design new material with some target set of properties. But whatever I do, I need data, right. Data are the most important thing in machine learning or deep learning. If you do not have large amount of data, you cannot do a good deep learning model. This is the biggest challenge in deep learning. So, what do you do there? So, as you understand, data is the most important thing for any kind of deep learning model. As you have seen, deep learning requires lot of data. I would say huge amount of data. Otherwise, deep learning will not provide you good predictions. And for discovery of new material, like you want to build a ropeway to moon from earth, what kind of material you will use, or design of new material with target properties, which are distinctly different from available in the world today, target set of properties. If you want to do this and using deep learning, it is very difficult to do nowadays, because you do not have sufficient data in the literature. So, in that case what you do? You will stop discovering, will stop doing something. Well, no, we can use what is known as a deep transfer learning. Remember the word transfer. Transfer means what? We learn, we make the model learn from data, large amount of data wherever it is available. So, we know that there are many conventional materials in which huge amount of data are available. So, we can make the model learn from those data and use this learning to design new materials or discover new materials, design new materials with target set of properties. That is the basic idea of this deep learning model. And so, therefore, it takes basically large amount of training data, hence requirement. Deep learning actually requires large amount of training data. So, therefore, this requirement is very stringent if you want to apply it for discover new materials or that. In addition, you also need a huge computational power, right, many times. So, therefore, new kind of CPUs or GPUs has to be built on to apply deep learning models. Many times they are not maybe available to you. So, what do you do in that sense? That is why you can use deep transfer learning model. So, the main reason actually used is this, that standard DL models demands lots of computational power, okay, like the ones which are GPU based, and we also need a lot of data. So, therefore, this is a significant barrier if you want to address some of the essential domain specific tasks, like as I told you, design of materials with set properties or discover a new kind of materials which are not present in the world at all. So, that is why this DTL or DL based transfer learning methods is very useful. What we do here? Here knowledge from a pre-trained model, earlier trained model can be transferred to a new DL model. It is useful because it allows you to train deep learning model with very little data. That is the key thing. So, this is something which is very important. We also human also do the same kind of things. If one before we this is very good for people like surgeons who do brain surgery. Okay. Before they undertake the brain surgery, they do a lot of exercise, mimic the brain surgery using robots. That is what is called pre-learning or pre-training ourselves. So, then once they learn from that, once they learn using robots how to make a brain surgery, deep brain surgery, then they can actually use this knowledge to the brain surgery. That is what is exactly used in deep transfer learning. Remember this. This is something which is going to change the design of materials in the materials world. So, what is the approach you use? Well, there are two steps here. One is called pre-training, other one is called fine tuning. So, therefore, we have two data sets, one is the large data sets, one is small data sets. Small data sets will be used to do the real job which you want, and large data sets will be used for pre-training. Okay, that is in some other domain, that is we call a source domain. This is taken from Professor Iqbal in a paper in SN Computer Science, very nice paper, you can read also. So, we have two different domains, one source domain in which large data sets, and these large data sets will be used for pre-training, that is what is called learning the task. And once it is pre-trained, then we can use this knowledge which is learned from pre-training to go to the data set number 2, which is smaller data sets, and these data sets is the target domain. That is what we want to do, or want to target, we want to get a new task, and that can be then easily done. So, therefore, even if you have very small data and you want to use deep learning model with that, this is possible using DTL. This is something which is unique, it is not easily available for many methods, and we always face this problem. Okay. Many of our researchers, we face this problem when you want to design a new materials or you want to discover new materials, we face the problem of data scarcity. And what do you do there? So, there this is going to be very useful. You can go back to a standard material which is available in large or discovered long ago. So, large amount of data are available with us, and we can use their data set as a large data sets, pre-train the model, tune it also, and this learning can be do that. Remember, the target and source domain cannot be widely different, then learning will not be common. So, if you want to talk about alloy design, if you are talking about material design, compositional design, then you have to use similar data sets. Does not matter, they are from different type of materials, but large and small data sets should be of similar types. So, let me talk about the detailed approaches of that. So, as I talked about it, that pre-training and fine tuning. What is fine tuning? Fine tuning involves taking a pre-trained network and training it further on a new task by adjusting the weights of the final layers. Remember, deep learning is basically based on neural network models, right. So, you have different layers, hidden layers, and you can put weights on each of these inputs, right, that we discussed a lot. Let us not go back into and spoil the time. So, fine tuning is not pre-training, remember, this involves taking a pre-trained network and training it further on a new task. How it is done? By simply adjusting the weights of the final layers, that is what is done. So, that first you pre-train the model in the large source of data, and after that you fine tune it for the new set of data by adjusting weights. That is, we have already discussed a lot about that. We discussed about how to measure errors also. You can go back to those lectures. Now, in deep learning, another important aspect is feature extraction or feature engineering. So, this is also part of DTL. This method uses the features learned from a pre-trained model as input to the new classifier. Okay, so that new classifier do not need to learn from scratch. Therefore, that is why I told these data sets of go back to the last slide, large data sets and small data sets, they cannot be from varied sources, like one compositional data set, other one is a mechanical property data set, right. Then it cannot learn properly. If you are talking about design of a new alloy, new glass, like okay, a new metallic glass or something, but you have to go back then data sets, large data sets of the normal glass which is available in literature, let us say window glass or all kinds of glasses which we normally use that large data sets, and then small data sets is nothing but what is the new metallic glass you want to discover for some applications. Okay. So, there should be similar type of things, otherwise it will not work. So, feature extraction is that means this method can use features which are learned from the pre-trained model as input to the new model. Well, there are many other things like multitasking learning. This also approach trains a single network on a multiple tasks simultaneously, and this allows the network to learn the shared representation that can be useful for many kinds of tasks. Okay. What does it mean is that it can train a single network on various kinds of tasks, that is what is called multitasking. Domain adaptation, this method means it is basically aimed to adapt pre-trained network to a new domain. Remember, you are learning from a new some source data which is large, that is a pre-trained network. So, therefore, this must be applied to a new domain, right. So, therefore, we have to align the feature representations of the source and the target domains properly. That is what I talked about it when you discussed about feature extensions. These are advanced things which you are learning. Now, what is transfer learning? That we are talking about it. This is nothing but this uses supervised and unsupervised learning to transfer the knowledge from pre-trained networks to a new network. Then the last part, the one term is knowledge distillations. This method trains a smaller network to mimic the behavior of a larger network, effectively transferring the knowledge from a large network to a smaller. Distillation, all of you understand, who does chemistry, they can easily understand. And then transfer learning with meta learning, like this method uses meta learning methods to learn how to learn from different tasks and transfer this knowledge to new task. That is called meta learning. We are in a meta world, that we are using a lot of meta sources. So, we can also learn from meta learning. These are the detailed approaches which in deep learning, deep transfer learning methods. Based on this, we can have different kinds of categories. Like you can have instances based things that uses instant in the source domain by appropriate weight. What does it mean? So, source, you have already talked about source domain, right. So, what about instance? Instant means what? I talked about instance. Instant means basically one data. Let us say I am doing an experiment where I am varying time, and I calculate the strain in the material, right. So, each one values let time 0.1 second, and this is strain which is percentage. The strain is about 1%, okay, and then 0.5, 1, 5, 10. So, these are my data, this 2, 5, 7, 15. So, instant means each of these, the one data with a level data, that is called instance. We talked about it during this basic definition of machine learning. So, basically it can, the one category of DTL uses instances in source domain by appropriate weight. Okay. So, learn. Okay. You can simply put the appropriate weights, and by the way, in any deep learning methods you have to use appropriate weights for the input variables, right. Second one is mapping based. What is that? It maps instances from the two domains, So, it maps instances from both the domains into a new data space. Why it is done? To find better similarity, because you are going to learn from one domain and use the other domain. So, you should find better similarity, that is called mapping based. One can also use network based. It reuses the partial of network pre-trained in the source domain. So, a new domain, the partial network of the pre-trained domain can be used, that is called network based. One can also use adversarial based. I already talked about GAN, right, generalized adversarial network. Please go back to my lecture. It uses adversarial technology to find transferable features that both suitable for the two domains, that is all. So, but this is not widely used, mostly instances based, mapping based and network based are widely used. So, each cases we are borrowing or using certain pre-trained aspects to the new domain, right. So, remember this plot which I shown you, large data set, small data set, source domain and target domain. So, new domain means target domain, source domains means the pre-trained domain. Okay. So, that is what we are talking about. Now, this is widely used, one of the most useful method to be used, and I can tell you that this is going to be game changer in all the machine learning methods available in the literature. So, please learn it properly. This is a very important method switcher. So, the most current research focusing on the supervised learning, this deep transfer knowledge based models can be used for further interest in future, and these techniques are useful in various kinds of things like visual recognitions, speech recognitions, spam filtering, discovery of new materials, design of new chemistry of materials, or even sentiment classifications or NLP. And I will discuss a lot of NLP in the next lecture, but for the sake of understanding, this DTL can be used in NLP also. So, this is the advantage of DTL. I hope you can understand very easily how to do that. So, now in the last part of the lecture, we will talk about deep reinforced learning, what is called DRL. But first let us talk about what is reinforced learning. I do not know whether you remember it or not, I talked about it briefly in the some lecture. It uses basically technique of making decisions to maximize the cumulative rewards in a particular environment, very difficult to understand, right. Well, in RL we use agent to learn in order to achieve the goal in an uncertain potentially complex environment. That is what it is. We use basically an agent to do that. So, agent will learn and then allow us to do the modeling. And why you do that? Because you want to achieve a goal in an uncertain and potentially complex environment. And how we do that? It perform actions and then receive feedback through reward or penalties. So, this agent will perform certain actions and it will receive some feedbacks. Feedback may be either rewards or penalties. That is how it will learn. So, agent is going to learn, and this is possible in a unknown territory or unknown environment, that the agent may fail in some experiments and may succeed in some experiments. That is why it is called maximize the cumulative rewards in a given environment. These techniques allow us to make decisions to do that. So, as compared to any supervised learning, which basically relies on the training data set with predefined answers, RL involves learning through experience, and this experience is by doing action, finding out whether the action lead to rewards or penalties. Okay, I hope it is clear. That is it. This is the agent based learning, by the way, in a very layman point of view, but agent learns by performing certain actions and the received feedback. So, the action can give you rewards or penalty, and idea is to do this kind of things in a potentially complex environment. So, what are the important features of RL? Well, first important feature is the agent. This is the learner or decision maker, remember. Second important feature is the environment. Everything the agent is doing or interacting with the environment, right. And then there are many other things like state. State is nothing but a specific situation the agent find itself. Action, all the moves the agent is taking, rewards or penalties, the feedback from the environment based on the action taken. Remember, these all to be built in your model if you want to do DRL. This all to be built in. Agent will interact with the environment in a specific situation where the agent will find in the specific state, and then you will do some actions or take some actions which will provide you some reward or penalties. That is what is called the reinforcement learning. So, we are reinforcing the learning of the agent. That is why it is called a reinforced learning. But then what is deep reinforced learning? Well, this is also using the concepts of environment and agent. Agent can perform a series of actions in the environment, each of which has an impact on the environmental state. That is what we talked about, right. Agent will perform a lot of actions in the environment, and these actions will have impact on the environmental states. Like it can obviously result in rewards, the feedback can be positive or it can be negative. So, it can lead to good actions or bad actions, okay, in a good state or bad states. So, purpose of the reinforced learning is to learn good action sequence to interaction with the environment. That is what it is. We want to have positive feedbacks, not the negative feedbacks, okay. But the actions can have both. So, therefore, agent will learn from both, and that is what is called the deep reinforced learning technique. Okay. So, now how it is implemented? Well, it has to integrate neural network with a reinforced learning architecture, and that is what it is. So, that means this will all of them will use deep neural networks, but neural network has to incorporate this reinforced learning architecture to allow the agents to learn appropriate action in a virtual environment. Okay. That is what is the way it is done. As you can see here, we shown that. So, you have an environment and then you have an agent. So, agent this is a network, you will use state S and action A, and then reward is R. State is defined as S, action is defined as A, and policy is defined as a P, I think, yeah, P, and the reward is defined as R, right. So, once this two has to be integrated, right, it has to integrate this architecture together, the neural network architecture with the reinforced learning architecture. This has to be integrated to create learn from the virtual environment. So, there are different types of reinforcement learnings, like you can have model based reinforced learning, which is based on learning on a transition model that enables from modeling the environment without interacting with it directly. So, that means what? The agent will learn from the environment without interacting with directly, it can interact with indirectly. And then you can also have model free, this is called model based, this is called model free. Model free means it will learn directly from the interaction with the environment, okay. Both are possible, but the indirect one is more widely used, because it will not, agent will not directly interact with the environment. And remember, this is used in various kind of things like NLP or alloy design, robotics, video games, computer visions, various kinds of things you can use. And this is something which is going to also change the dynamics of the machine learning methods. Professor Iqbal already described in his paper that this method actually can use can learn directly from the raw high dimensional visual inputs. In the real world, these solutions can be used in video games widely, robotics, alloy design, natural language processing, or even computer visions. Okay. So, in this case, in this particular things, we can mention that there is something called a Q learning, and then Q learning is basically nothing but a type of DRL technique. And in Q learning, actually it is very popular model free deep learning, deep reinforced learning techniques, and in the for determining the best action selection policy of any Markov decision process, what is called as a MDP, Markov decision process. Markov decision process is widely used in various kinds of deep learning methods. So, Q learning uses that. Q learning is basically model free RL technique for determining the best action selection policy for any Markov decision process or MDP. By the way, MDP is a mathematical framework for modeling decisions based on state, action, rewards. In addition, you can have Q networks, double DQN, bidirectional learning also, we talked about it earlier also, multi-kernel control, all kinds of things are possible, different varieties of this actually. You can have Q networks, double DQN, bidirectional learning, multi-kernel controls, all kinds of things are possible, but Q learning is widely used in Markov decision process. Okay. So, to make the decisions using this Markov decision process MDP, Q learning is widely used. I hope I have given you a good sense of understanding about both DTL and DRL in the last 45 minutes or so, and these two actually very important advanced deep learning methods, both can be used in materials science and engineering widely, And not only that, you can use it for alloy design, you can use for computer visions, you can use for understanding microstructures. Okay. But you see both of them actually are operated in a different way. One is using DTL is using transfer knowledge, that is what it can be used for when you have small amount of data. DRL uses reinforcement learning, basically based on how an agent learns from environment. So, both has their unique ways of utilizations, and that can be utilized to different kinds of models. I hope you can use it for further purposes to understand these aspects. So, let me stop it here, and we will come back in the next lecture, more discussion on NLP. At the same time, for the some of the lectures we will have to discuss about errors and preprocessing of data. That is something which we will do after a discussion on NLPs. Thank you.